This is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today, I want to discuss about problem solving on simply supported beams with a point loads and UDL. So already we have discussed about cantilever beam with point load and UDL in previous session. So how to solve the problems we have seen. So in this session, we will learn how to solve the problems on simply supported beam whenever the point loads are acting and the UDL is acting. So how to draw the shear force and bending moment diagrams we will. So first of all, you should know about course outcome, that is CO2. So illustrate the shear force and bending moment diagrams or distribution in beams for analyzing the structural behavior under various loads. So whenever the beam is subjected to various loads, the student should be able to illustrate the shear force and bending moment diagrams. So after completion of this module, so the students can analyze and they can draw the SF and BF diagrams, BM diagrams, bending moment diagrams. So we'll see first one problem with the point load. The problem solving on simply supported beam with the point loads. The given problem is a simply supported beam of length 6 meters. The length of the beam is 6 meters. It carries point load of 3 kilonewtons and 6 kilonewtons at a distance of 2 meters, 4 meters from the left hand. 2 meters and 4 meters from the left hand. So you know the simply supported beam having two supports, one is right and one is left. So at a distance of 2 meters and 4 meters from the left hand, are taking the left hand side, the loads are acting at 2 meters from the 2 meters from the left hand is 3 kilonewtons and 4 meters 6 kilonewtons. For this load diagram, draw the shear force and bending moment diagrams for the beam. So how to draw the shear force and bending moment diagram for the given load diagram I will explain in this session. So already you know in previous session the cantilever beam case, so already we have calculated and also drawn the shear force and bending moment. First you should draw the shear force diagram. So for the shear force diagram require the shear forces. So that's why first you need to calculate the shear forces acting on the beam and then draw the diagram. Similarly, bending moment. So calculate bending moment and then draw the diagram. But while calculating this shear force and bending moment, you should follow some rules. Already we have discussed it in the theory part and sign convention also you know. So those rules and then the sign conventions apply for this problem. See in this diagram, so this is a solution part. So the given load diagram, the given load diagram is like this. So what he has given, the beam of length 6 meters and point loads 2 meters distance from the 2 meters. So after the first, not given this 5 kilonewton and 4 kilonewton. So after calculating the reaction forces, we have substituted in this diagram. So 3 kilonewtons from the 2 meters distance from left hand, and from left hand side 4 meters distance, that is 6 kilonewtons. So the entire length is 6 meters shown in this. And for this simply supported beam, first calculate the shear force. So for this, here two supports are there. One is A and B. These are point loads C and D. That's why reaction forces calculate. So that is denoted with RA and RB. So what is RA and RB? RA is reaction force at A support, RA and RB. So RA is at A, RB reaction force at B. So first calculate these two reaction forces. In the case of simply supported beam, the first step is so calculate reaction forces. So how do we calculate? So the downward forces and the vertical forces and the downward forces are equal. So that is equate the for balancing for equilibrium. So what are the forces acting? The vertical force, vertical loads is equal to the upward force. Here upward force is RA plus RB reaction forces. These RA and RB. So RA plus RB must be equal to the downward vertical loads, whatever loads acting the point loads on this beam, that is 3 kilonewton per 6 kilonewton. So that is shown here. So here RA plus RB is equal to 9 kilonewtons. Now calculate individual forces, reaction forces RA and RB. So how do you calculate? Taking moments of the force about A. So in about A, taking moments RA, I will mark here RA and RB. Now the RA into 0, what is the distance acting from its left side? There is no distance. So here RA acting, RA multiply with 0 plus next 3 kilonewton downward, 3 into 2. So 3 multiply with force multiply with distance. So what is the distance? That is 2 plus 6 multiply with 4 minus upward this one 6 RB multiply with 6. So here take any section between this A and B to calculate from right side or either left side. So here see this at this reaction force, the distance from the left hand side is support is 6 meters. So the RB is acting with 6 meters distance. So that the RB multiply with 6. For this, the RA, there is no distance here. 0. That's why I have taken 0. Clear? That is equal to 0. The taking moments about A is equal to 0. So that 6 and 6 plus 6 multiply with 4, 24. 30 minus 6 RB. Now calculate the RB is equal to 5 kilonewtons. RA is equal to, why? Because already you know RA plus RB is equal to 9. So RB is calculated 5. So RA plus 5 is equal to 9 and RA is equal to 9 minus 5, 4 kilonewton. So that's why here in this diagram substituted after calculation of RA and RB, RA is 4 kilonewtons and RB is 5 kilonewtons. Now calculate the shear forces. Shear forces at each and every point. So very, very important in this step. Now we are calculating shear force from B and the right side end at B. See here what are the forces acting at this B left side and right side section. So what are the shear force acting at the right side and shear force at B? First one is the shear force at B right. Is there any forces? Right side? No, there is no forces here. So here 0. There is no forces here. 0. So that's why at B is 0. So what is the left side force? The left side, the B left side is 5 kilonewtons. But we are used here negative sign. So upward force. So here negative 5 kilonewtons is acting the left side. So right side there is no force. So this force remains constant up to C. So now calculate what is the shear force C right and shear force C left. What is the C right? C right up to C. This force is remains constant, that is minus 5. And C right is minus 5. Okay, C left is, so what is the C left? C left, so minus 5 carries. Here acting the vertical load 6 kilonewton. So that is minus 5 plus 6, that is 1 kilonewton. So the left side is for every point, suppose here you have taken first one B left and right, at C right and left, here also same right and left, and left right and left. But each and every section need to calculate. B at B right and left, C right and left, D right and left, and A right and left. So what are the forces acting this day at each and every point? So at D right is up to D point, this force is remains constant. It carries up to D, A and RB. Clear? So and again here at A right, D right is 1 kilo, D left is 1 plus 3. So here 3 kilonewtons acting downward. So that is 4 kilonewton. Now the remaining A point, the shear force A right is 4 kilonewtons remain constant, and A left is 0. A left is 0. So why? Because here 4 kilonewton minus 4 kilonewton. There is no other forces. So 4 minus 4. This 4 carry forward up to right, and again the 4 is acting upwards. So that's why the shear force at A left is 0. Now draw the shear force diagram. First you draw the first calculate the bending moment, and then you can draw the by using shear force and bending moment values. You can draw the shear force and bending moment diagram. Clear? Similarly, calculate the bending moment. So the bending moment at B is 0. So do we calculate? So again here draw one diagram, the load diagram, RA and RB. 4 kilonewton, 5 kilonewton. A, B, C, and D. The total is 6, and here 2 and 2, right? 2 and 2 meters. And what are the forces? Here 6 and 3. 6 kilonewton and 3 kilonewton. Now bending moment at B point 0. So always see the bending moment at their ends. For simply supported case 0. The bending moment is B is 0, and similarly the A also 0. So here see the bending moment at B 0, and calculate the C. At C point, the bending moment is 5 kilonewton, multiply with the distance 2. So the remaining distance is here 2. Okay. So 5 kilonewton multiply with 2. So 10 kilonewton meter. Similarly at D, this 5 multiply with 4 at D, 5 kilonewton 4 meter. So 5 kilonewton multiply with 4 minus at C. C is 6 kilonewton multiply with 2 meters. So that 5 multiply 4 minus 6, 2, that is 8 kilonewton meter. At A is 5 kilonewton 5 multiply with 6 minus 6 into 4 minus 3 into 2. So that you will get 0. So here you have calculated shear force and bending moment values at each and every point. Now draw the shear force diagram and bending moment diagram for the calculated values. So this is load diagram and draw one AB, that is baseline. So the above is positive and below is negative. So here see at B 5 kilonewtons, that is negative. The shear force values, the left is 5 kilonewtons, right is C, right is minus 5, and here 1 kilonewton, and draw the vertical line upward, and then this remains constant up to D, and then here again 3 kilonewtons acting, the vertical load, and it remains constant up to A point. So already shown here baseline. This is a shear force diagram. Similarly, for calculated values, the bending moment diagram. So A to B, the A to B is baseline. At B is 0. Starting point is 0, 0 to at D. So what is the, sorry, the C. C here shown here and D. And C is 10 kilonewton meter and D is 8 kilonewton meter. So 8, 10 and 8. So again 0, A is. It follows the straight line. So why? Because it's a point load. So positive bending moment. The bending moment, all values are in positive. So we got the bending moment diagram. Like this, need to draw the shear force and bending moment diagram for the given point load beams. So that is simply supported beams. Now we will see the problem solving simply supported beam with UDL, uniformly distributed load. So draw the shear force and bending moment diagrams for the simply supported beam of length is 9 meters and carrying a uniformly distributed load of 10 kilonewton per meter for a distance of 6 meters from the left end. Also calculate the maximum bending moment on the section. So here what he has asked, first to draw the shear force and bending moment diagram. So and then maximum bending moment on the section. You need to identify the maximum bending moment where it will occur. See, the first load diagram is the given RA and RB. So later you can substitute these two values. So the 10 kilonewton per meter, that is UDL load, and 6 meters A to C, and A to B is 9 meters. And RA plus RB is 60 kilonewton. So why? Because here given load is UDL. So convert into point load. So that is W into length. So here 10 kilonewton per meter multiply with 6 meter. So now we will get 60 kilonewtons. So that is RA plus RB. Now calculate RA RB values by taking moments of the force about A. Already we have seen in the previous case. Same procedure here also apply. RA into 0. There is no force or no distance from acting at this A point. RA into 0 plus 10 into 60. Here load is, the entire load is converted into point load. So that is 60 kilonewton. So 60 kilonewton multiply with what is the distance here? Half of the distance you have to take, 6 by 2. Half of the length. Well, calculating moments, W into L by 2 minus 9. So what is the 9 here? RB. RB multiply with 9. So now calculate. You will get RB is equal to 20 and RA is equal to 40. So why? RA plus RB is equal to 60 kilonewtons. So RB is equal to 20 means the remaining RA is 40. Now calculate the shear forces and bending moment values at all points of the beam. Shear force. Same shear force at B right, 0. Once again draw here diagram. RA and RB at C, UDL 10 kilon per meter, and here 6, and total is 9. So RA is 40 and RB is 20 kilonewton. Now calculate the shear force. B right, there is no shear force, 0. B left is 20 kilonewtons, that is acting upwards, negative. Downward, positive. The sign convention already we have seen. So 9 your shear force, the C right is minus 20, remains constant up to C. At the C left is a acting UDL force, that is converted into point load, that is minus 20 plus 10 into 6, that is 60. So A right is 40 kilonewtons. A left is 0. There is no shear force. Similarly, the bending moment. See, for this bending moment at B is 0. There always the simply supported case at their support ends there is no bending moment. At C point, the bending moment is 20 multiply with 3. So 3, the 20 to multiply with 3, that is 60 kilonewton meter. So here at C right is 20 kilonewton and C left also 20 kilonewton. So here at this C point, the 20 multiply with 3, the remaining distance is 3. And then at A, 20 multiply with this total entire distance minus this UDL part. So W into L by 2. So already, so W into L by 2. So already converted this one. So that W, capital W into L by 2. So at A point, there is no bending moment. See here, draw the shear force and bending moment diagrams for the calculated shear forces. So each and every point already we have calculated, and then bending moment also we have seen. Now draw the shear force and diagram at B point 20 and B to C here, C here, from take X value from here to here D, and again here positive. So here one thing you can observe here, the bending moment changes its the shear force diagram, the values are changes its sign, positive negative to positive. So now you can take second part. So what he has asked, first one is shear force and bending moment diagram already drawn. The second one is also calculate the maximum bending moment. So where it will occur. The maximum bending moment always occur at whenever the sign converts, the changes its for shear force value uh, changes its sign. So that is negative to positive enter here at this intersection, the point that is G, D. So at this point, you need to calculate. So there will be a maximum bending moment. So that here, take from X distance here. So from here to here 6. So that's this length is 6 minus X. So already you know the parabolic curvature. So the bending moment for the values, calculated values B to C, that is straight line. So 60 kilonewton with B0 and A0. So now calculate the X part. So what is the distance at which occurred the maximum bending moment? We don't know. Need to calculate. Take here similar triangles. X by 20 minus 6 minus X by 40. Similar triangles. X with this one, this A, B, A. You can see, you can write here D, E, A, D, E. And here you can see F, D, C, F. Similar triangles. Similar triangles are A, E, D, and then D, C, F. So compare these two triangles, we will get X value. So apply similar triangles ratios here. So 60 X is equal to 120 and X is equal to 2 meters. So the bending moment now calculate at X. At X value, so 20 into 5 here, the distance is X is 2. So 2 plus 3, 5, here remaining value is here 3. So 20 into 5 minus 10 into 2, the remaining value here. The 6 minus 3 here. So load is here, UDL load 10 kilonewton meter. So 10, 2 into 2 by 2. W into L, WL into L by 2. So we will get 80 kilonewton meter. So that is shown here in this diagram, 80. So 2, C 60, and then D at this point is maximum bending moment will be occur at B point 0, at A point 0. At bending, this is 60 and 80. So clearly shown in this diagram. So like this, you need to calculate shear force and bending moment values, and also how to draw the shear force and bending moment diagrams for the point load simply supported beam and UDL simply supported beam we have discussed. So these are the references I have taken. That is Ramamrutam, Strength of Materials, and the publishers are Dhanapati Rai and R.K. Bansal, the textbook of Strength of Materials title, and then R.S. Kurmi and Gupta, that is Strength of Material title, and publishers are Chand and Co. So take one any reference textbook for further more clarification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.